Hello and good day to you. So today I'm doing a video on time analysis. I'm not a financial advisor, but I will be discussing this in terms of stock prices because I think that's a really good metaphor to think about this video and time series analysis in general. Also, as the saying goes, most mathematicians agree that the stock market is completely random nonsense, but nonetheless people tend to make millions out of it and make millions out of it on a day-to-day basis. So this video is in homage to that concept, and this isn't real data. It's produced by a function up here. It's completely random. And something to first point out is this and this data is the same data, the same function, just you can see here. The only value difference is one is produced where the coefficient for randomness was 1 and one was produced by the coefficient for randomness was 0.2. Now you can see with 0.2 what happens is the Brownian motion for the values of the prediction is so small that it tends to be equally likely to wander back to zero as it is to do anything else. So there's no accumulation of randomness. It starts off on a trajectory and it goes up and up and up. But when you take that away and you have a larger amount of randomness in the data, you can get shocks like this, where a shock at the beginning of your data can cause one to diverge quite largely from the another value. And that's worth considering because that's one explanation of why stocks and shares can be overvalued. You could have had a really great year a couple of years back and a company's still riding high on it, and to sort of look for whether values are overvalued and to sort of get behind some of the events is what we're here to look at today. That being said, I'm not a stock market expert. Don't try this at home and unless you take responsibility. So what we've got next is, having produced that data, R gives us a function called autocorrelation function. And if I take the value of S1 where it's 0.2, it will look at the different values and see how much of a shock they represent compared to the values immediately around it. So as you can see here, the only real shock with the first value is the starting set at 90 was a big difference, and then it sort of averaged itself around the mean, and it's only very small, tiny little flutters. And that goes down to what we said about Brownian motion. It is just a little. If this was particle physics, it's just a little particle going whoop, 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 all along the line. You look at the next plot, which was for SS1, which was the large black line. Here, you can see that actually the randomness that comes out is huge. That using autocorrelation function to look for and compare the level of changes between the values, every single lag value. So every change is quite big. You could conclude that there's a lot of randomness going on in this data, and if this was maybe a stock, you could conclude this is this stock, whatever change is happening within it, it's normal, it's a standard slow increase. If there is a slow increase, I mean there is no increase in this one, but making the point. And this one, it's just all over the place, it's random, it's changing all the time, and maybe that might change your mind on how you then think to proceed. Now, I sort of intend to go into some more detail with time series analysis. I'd really like to get my head around how it applies to stocks and shares. Might even, take a little bit of a chance on the stock market if just for science, completely for science, if I get good at it. But yeah, it's interesting seeing behind the veil and getting your head around it, because I guess previously I think in one of my previous videos I talked about time series analysis as very much like regression, where the previous value is using your least squares. And I'm now being told, when I did my research for this video, the stuff that came out was things like, well, uses maximum likelihood instead, and I'm like, well, there's another function I need to learn. So it's going to be interesting. I think the maths for this is a little harder because it involves a load of stochastic stuff. It's not just looking for trends like regression is. It involves realizing and dealing with shocks like this, where things that are basically the same, black, red and green in this, are exactly the same piece of data, produced exactly the same way, but random chance has caused them to diverge, chaos has caused them to split apart. And getting your head around how to deal with that will be my next topic, and looking how you can take non-stationary data like this and make it stationary. So thanks, have a good day, bye.